Sorry, I think we got cut off there. Okay, so 5D filled with 10, and then after the 4D filled with 10, and then we go to the P block, which is a 5P, and that is full. Put 6 in there. And after the 5P, so we are here, we go to the 6S. So we're going to put a 6S in here with 2. Now, after the 6S, remember, we don't jump into the 5D first. We have to pull the F's in first. So we're going to fill this 4F. Okay, so this is going to be long, and it's going to have 7 orbitals, and each will be filled to give us a total of 14 electrons across that row of metals. After the 4F is done, we now jump back into the D, 3, 4. This is the 5D, and we're only going over 3. So we're going to put a 5D in here, and we're just going to put in 3 electrons. We are done. And this is as big as you would ever get, I'd ever ask you to do with these energy level diagrams, because there's a shortcut to do this, which allows us to do the really big ones. So this has 3 unpaired electrons, therefore this is paramagnetic. Okay, so what I'm going to do is I'm going to give you some practice for you to do after this. Okay? All right. Next thing to show you, and again, the only reason I'm showing you this is because to try to write all of this out without showing you is probably more difficult to understand than what you're trying to do right now. Okay, so next thing is I want to introduce a couple of terms to you, and then I'm going to show you how to fill, to do diagrams that involve cations and anions. All right, so oxidation state, you know them as ionic charges. So to make a cation, you need a positive charge. Anion, you need a negative charge. We know that we have some atoms that have a fixed charge, like oxygen has a fixed charge of -2, chlorine would have a fixed charge of -1, but then we have our transition metals like copper and iron and nickel that have more than one charge. They're on the back of your periodic table. Okay, so I'll be showing you how to make those. The other thing you may or may not be familiar with is the term isoelectronic, which simply means that when you compare the number of electrons between atoms and ions, for them to be isoelectronic, they have to be the same. So for example, if you were to take neon, so neon you know has 10 electrons, and we know it has 10 electrons because its atomic number is 10, so 10 protons, 10 electrons to stay neutral. So we know that neon has 10 electrons, but so do all of these. So what we did with fluorine is, if you go to your periodic table, we took fluorine, has 9E, and what we did is we added 1. That gives us 10 electrons. Oxygen, we know our periodic table has 8E, and we added 2 to make it a stable ion, which is also 10. For nitrogen, we know it has 7 electrons. We added 3 to get the -3 charge. If you look where sodium is on your periodic table, to make it a cation, it has to lose an electron. So it has 11 electrons, but we took away 1 to make it a cation. Magnesium has 12 electrons. We took away 1. That gives it 10. And aluminum has 13 electrons. We take away 3, and that's why we get 10. So these all have 10 electrons, therefore they are isoelectronic. Okay. So rule for forming anions. You're going to draw the energy level diagram for the atom, and you're going to add the electrons you need to fill the highest orbital. So what you're really filling are the S's and the P's. For cations, it's the opposite. So for cations, you want to remove electrons to empty their highest shell. So you're going to be emptying their S and their P orbitals. Okay, so 6 examples that we'll work through. and then I'm going to do one more set of examples, and then we're going to stop, and I'm going to give you some practice. It'll be posted on, well, you have it on your sheets. Okay. All right. So let's look at these. First of all, we have nitride. So nitride, you know, is nitrogen, which means it has to form a negative ion. So go into your periodic table. Nitrogen is here. It's number 7. So you're going to start with hydrogen and do your energy level diagram to nitrogen. Okay. So N is here. And what we're going to do with N is we're going to have a 1s with 2 electrons, a 2s with 2 electrons. That takes us to beryllium. And then we're going to do a 2p with 1, 2, 3 electrons, because in the p we're counting over 1, 2, 3. All right. So we know that this has to be an N3.